Dear Professor, I would like to submit my homework 6 sharp about explain test system edification until best beat more than 80%. The homework task is create the model system and get the result. For complete the task, I need use Simulink part of library. First, I will create this block. Use each block in library browser of Simulink, like this. Just the imported part of the Simulink. This, I will introduce each block about the function and how to use it. In MATLAB, the SIN function is typically represented using the built-in SIN function. This function computes the sign of an angle provided in radians, and SIN1 can be created using this function along with a time vector. We can find it from Simulink source and choose the SIN1. For the transfer function, in MATLAB, transfer functions are used to represent and analyze linear time invariant system in the frequency domain. MATLAB has built-in functions for creating and manipulating transfer functions, which are typically represented as ratios of polynomial in the Laplace domain or the Z domain. We can find it from Simulink and the continuous and choose the transfer function. The second block is the transport delay. In MATLAB, transport delay is used to represent a time delay in a signal or a system. This is particularly important in control systems and simulations where the response of a system is delayed by a central amount of time. We can find it from Simulink continuous and choose the transport delay block. The fourth block is two workspace. We can say there have 4 parts about two workspace. This 1, 2, 3, and 4. The two workspace function in MATLAB is a Simulink block that is used to send simulation data from a Simulink model to the MATLAB workspace for logs data. This is useful when I want to analyze, process, or visualize data after a simulation has run. The two workspace block only logs data after the simulation has completed. I can use multiple two-spoke blocks to log different singles or variables. If I want to export real-time data during simulation, consider using the scope or two-file block. We can find it from Simulink and Sinks to choose the two workspace block. Next block is scope block. There have one, two, three, about have three parts. The scope block in MATLAB, special in Simulink, is a tool used to visualize and monitor singles during a simulation. It functions like an oscilloscope, allowing you to see the waveform of any signal as it evolves over simulation time. This is particularly useful for analyzing system behavior, debugging models, and verifying the output of a simulation. You can connect multiple singles to a single scope block, allowing you to monitor multiple waveforms at the same time. Each single will be shown on a different axis. You can also set up multiple monitors to display waveform independently. We can find the scope from the Simulink sinks and choose the scope block. The sixth block is gate block. The gate block in MATLAB Simulink is used to multiply an input signal by a constant value. This is a fundamental block in control system and single process, often used for scaling signals or tuning system parameters. The value set is 10. That means it multiplies the initial signal by 10. We can find it from Simulink commonly used block and choose the game. The next block is constant block. The constant block in MATLAB Simulink is used to provide a constant value as an input signal throughout a simulation. This is often used for setting initial conditions, creating reference signals, or providing fixed parameters in models. Next is there have set value is just next is negative 3, and I will simulation and change the value will be the negative 9.5. We can find it from Simulink source and choose the constant block. The 80s block is sum block. The sum block is used to perform arithmetic operations on input signal, such as addition or subtraction. We can find it from the Simulink math operations and choose the sum. The last the last block is max. The max block in meta-enabled Simulink is used to combine multiple input signals into a single composite signal, often called a vector signal. This allows for grouping several scale signals together so that they can be processed, routed, or displayed as a single entity. The max block is used for arranging signals and the semi-planar models when dealing with material-related signals. And there have as a display, we can choose. Oh no. We can find the max block from Simulink single routing and choose the max block. This display just shows the result like this. We can find it from the Simulink Things display and choose the display block. Okay, this is my theoretical introduction. Next, I will show how to solve this model system in Simulink Solve world. When I run the system, we will get the scope show like this. The scope block show. The blue line is our set value, and the yellow line is our real value. This is scope 1 block show like this. There have two figures. The first figure from the scope 2 block show. The value is set for -3. We can say the yellow line is our set, but the blue line like this, the highest more than 10, about 15, more than 15. But the lowest, just like this, are not -5. So we can change and or simulate another value. For the second figure, we change the constant equal -9.5 and get the figure like this. The blue line, the highest and the lowest near to the 10, more than 18%. So the value is right. Okay, this is theoretical introduction. For the Simulink software, we can open the new Simulink and change the name is homework 6 sharp. We can open the library overall and choose the Simulink part, and where from the source we can choose the constant, okay, here, and the way the sine wave for the here. We can from the continuous and choose the transfer fact, okay, and and in the continuous we will choose the transport delay, okay, here, okay, and we come to the sinks. In the sinks we will choose the discipline, okay, and the scope. In the system I have 3 scope, and I have 4 2 workspace, 2 3 3 4, okay, and in the commonly used block we will change there. We can change the constant from here, and from the continuous we will change the gain, okay, and we can from the math operation change the sum, or sum is sum, it's here, and we can from the single routine change the max, okay, and okay, contest, oh no, okay, okay, the block I have complete choice, and will click the line, okay, scope, and the scope 1 is here, the 2 workspace is here, have the space here, into this, here, this, come here, and the scope, it's here. Okay. Make this. Okay. This here. Okay. Mm, for this girl. Okay. Connect and the constant connect in the max. Okay. And net here connect the second line. Okay. And the input space. Okay. Here. Here. Okay. Just like for the specs 2 for the output. Okay. Connect in the here. The two space workspace 3 for the input input connect this. Okay, connect this. Okay, and the input connect the max. Okay, we can move it. Okay. Oh no. Okay, and the last scope and the display here. Okay, connect and the show display shows the data. Now, let me check it. Move it and move it back. Okay, it's feel nice. Okay, well, I change this temp and this from the -3 and change the name. You can change about 9272 and this about 3. Oh no 1 205.5 and 1.056 E4. That's right. Okay, and got this, move it and change is bigger. Okay, move it. Okay, and we'll choose this and choose the automo, uh, uh, automatical. Okay, we can choose this. Okay, and this will run it 3 -3 10. Okay, we can run it. This we can use the scroll tool, scroll 1, and the scroll here. We can choose this. Scroll to there. We find the figure. This flow I check. We can find this have arrow. And oh, okay. Okay, it's right. Okay, let's run it. We can this. Put this here and go to the scale 1 like this. The scale 2 like this. Okay, we can change this for the 9.5 and run again. We can change. Okay, we can see the figure, the line are different from the PPT image. We can check it like this. Or I can see this wrong. Now have me wrong about it. So, okay. Change this here. Okay, let me change this the first and the here. The input from the first second is the second point is 1, 2, 3, and this from the output. Okay. point the input from the input, it's here, and this for the input. Okay, change the name is in input. This change the name is output. Okay, the input, then let me change. Group. We can change this and run. We can get the display, the score like this. We can find this, the error that is wrong. Okay, we can change the constant for the negative 9.5 and run again. We can got the 9. The 9 is about 19%. It's okay. Okay, this is my all introduction about this homework. Thank you.